Today we've learned everything that we need to know about assignment 2. And so I'm going to go over first, I'll show a demo of the assignment, and that'll just take a minute or two. And then I will go through some slides that I have that talk about the new architecture that we're using for the code for assignment 2. It's much better than assignment 1, which was sort of this free-form thing that you all got to do however you wanted. And then I'll talk a little bit about circles, because there are a lot of circles in this assignment and the stuff we'll need to know about those. And then I'll go through the README file again, so the complete text description of the assignment. And at the end of that, I've got like a set of hints. And the hints are sort of the order that you should do the things in the assignment. And the order is there so, you are always doing things that only depend on things that you've already done. So you wouldn't want to start with something that you can't test because other things aren't done. And as I go through that, I'll go through the skeleton code that I have, and you'll all be set for the assignment. And the assignment the link will become active you wake up tomorrow morning, and the link will be active for you to download. And assignment 1 is due tonight at 11:59, so just be aware of that. And the only real difference between submission for assignment 1 and the rest of the assignments is for assignment 1, you are just submitting main.cpp and no other files. And for the rest of the assignments, you'll be zipping up the source directory and submitting that zip file, because there are multiple files in the other assignments. So let's go ahead here and have a look at a demo of the assignment. So this is the solution here. And this is a clone of a game called Geometry Wars. And on my screen here, there's like a checkerboard background, but it's hard to make that out on the screen. But I'm controlling this player here. Actually, let me restart this. And what I'm going to do is I am going to pause the spawning of the enemies. So I'll kill the one enemy that's there, and I'll pause the spawning. So I'm controlling this player that's outlined in red, and I'm moving around the game area with the W, A, S, and D keys. The parameters of the movement, of the window size, and of a bunch of other things are all specified in a config file, and I'll get to that configuration file once we get into the README file. And so, for example here, if you can see the mouse pointer, I can left-click to shoot the mouse, or to shoot toward the mouse, and then these bullets come out, and you can see that the bullets only live for a certain amount of time. All of that is defined in the config file as well. And as I shoot bullets, they come out and they fade away as their lifespan ticks down. Now, over here in the UI, I'm showing all the different systems that we have, and I've turned off the spawning system just so I can demonstrate the assignment without this like panicked look on my face as I get killed by enemies. So over here in my solution code, I have a manual spawning button. You may want to implement this so you can do the same sort of testing. If I spawn an enemy, that enemy will spawn somewhere on the screen. It's going to have some number of sides. It's going to be given a random color, and it bounces around, and if it makes contact with me, we are both destroyed. I spawn back at the middle, and when an enemy dies, it spawns as many smaller enemies as it has sides. So for example, this is a purple square with 4 sides, so it will spawn 4 purple smaller enemies that each have 4 sides. And each of these enemies is going to have a certain number of points associated with it, and as I kill it, my score increases up in the top left by that number of points. And also I have a special weapon that I can fire with the right mouse button, and my special weapon is a bit overpowered. It just fires bullets all over, and you're going to come up with your own special weapon that you just think of and implement for the assignment. Over here in the UI, you are also going to have to implement this, so I'm going to turn on spawning. In the config file, right now, by default, it specifies every 60 frames. So if this is running at 60 frames per second, every 1 second, we're going to spawn a new enemy on the screen. The enemies do not collide with each other, but they do collide with the bullets and the player and the sides of the window. Your window will probably be a little bit smaller when I give you the config file. I just wanted to make this as close to full screen as possible just for the demo. You can see here that if I turn off the systems, so this is everything still working except the movement. So if I fire bullets, the bullets still have lifespans, etc., but they don't move anywhere. I can also turn off, independently of that, the lifespan system. So my bullets would live forever without the lifespan system, but what I'm doing right now is firing a bunch of bullets in all directions. But because they never die, and because they never move, nothing is happening until I turn back on the movement system and all the bullets go out, right? So this is like, this UI here is a really interesting way that you can use to debug and stuff with your game. So having this sort of user interface where you can independently turn off all of these ECS systems is a really powerful tool for debugging, playtesting your game, etc. The last thing I'll show is over here, I also have something called, and let me restart things so there aren't 500 enemies on the screen. So I'm going to turn off the spawning. Over here I have, I'm going to be killed here. So the entity manager part of the user interface, and I'll just make this a little bit bigger. Over here I have some collapsing tabs here, and what this shows is all the entities in the game. So for example, if I look at all the enemies in the game, well, there aren't any enemies right now. I'll spawn some in a second. But if I shoot some bullets, if I do this, you can see that there's these bullets. And as they are created and destroyed in real time, we see them here in this user interface. So this is a really nice debugging tool as well for being able to tell. So for example, if I turn off lifespan and then I shoot some bullets, they'll just continue on forever, right? Because they're not being killed by the lifespan. And you can see, oh crap, I've got all of these bullets that are like all around the level that I actually don't want them to be there. So that's one thing that's really nice about this. If I turn on the spawning here, then I can see now there are enemies spawning. And the cool thing about this UI is I can hit this delete button here to actually delete entities as well. So this is like, I can manage the entity manager through this debugging interface, and you can help that. So if you were to release this game, you know, and charge some money for it on Steam or whatever, you probably wouldn't include this debug interface. But this is the great thing about IamGUI. It's really quick to whip up a UI like this to help you debug your game. So you will be making this UI that I have here. And like if I turn off the UI, I actually don't have a button to turn it back on. So maybe I won't include these two buttons down here. But you can increase the spawn rate of things. So if I turn it down to 7 here, or maybe let's go to 5. So what's 60 divided by 5? That's 12. So we're spawning about 12 enemies per second. And now here, this isn't, you know, the most interesting game because I don't have a set amount of lives or anything like that. I'm just spawning back at the beginning. But we're not releasing AAA games here. It's more about the game programming. But you can see it runs at a really smooth frame rate. You can have, let's see, can I put this all the way down? How many things could we have on the screen? We could have probably hundreds of thousands of things on the screen and the game wouldn't slow down. So you'll be making, this is the game that you'll be making. Okay, so that's the game. It doesn't take long to explain the game, but of course I want to go through all the nitty-gritty details, which does take a little bit of time to explain. So what I'm going to do now, let me turn back on this light here, sort of blind you all. I'm going to go through some slides that I have about the updates to the architecture for this assignment. So let's play this and then get my laser pointer. Cool. So yeah, lecture number 6, we're talking about the assignment 2 architecture and some more about the circles and the collisions and stuff that we'll be using for this. So for assignment 1, that was really just, hey, some of you probably haven't looked at C++ before, you've never used the APIs like SFML or IamGUI, and all the functionality of that was in this one file called main.cpp, because it was a very, very simple project. Assignment 2, we are going to separate the different functionality of different classes into different files, into different classes and their own files for each class. We're going to be writing our own vec2 class that we're going to be using for all the positions, velocities, collisions, stuff like this. This is where we first are actually going to get to use ECS, which is really exciting. I'll show those implementations and how to use those. We're going to have an entity manager. The entity manager has been completed for you except for the deletion of entities, which I want you to have a go at on your own. And the ECS systems functionality is going to be in this game object that's going to handle the main gameplay for our game. So what we have, if we want like a high-level overview, is we have this game engine that's going to be the game class. The game class is going to have a bunch of functions, and those are the systems, like we're going to have a movement system, a collision system, etc. It's also going to store the entity manager. which holds our entities, and the entities are going to hold our components. And so that's the high-level data structure of our assignment, or the structure of the data for our assignment. Our components that we're using, we have several components that we're going to use for this game engine, or for this particular assignment. As you get into more and more complex games, you'll probably introduce more and more components to your games in order to implement those game mechanics. But this is a relatively simple game, so we can get away with having just 6 or 7 different components. Just keep in mind that these are all pure data. They are stored within the entity class in a component tuple. Each component is going to be implemented as its own class, and it's going to be stored in the entity. So for example here, we're going to have our transform, which stores the position, the velocity, the scale, and the angle of each of our entities. We're going to have a shape component, and that's just going to store the SFML circle shape that we're using to draw to the screen. We're going to have a collision component, and that's going to store the collision radius that we're actually using to detect collisions. We're going to have a score component, so I have a little formula for the score in the README file, but this is basically just going to, whenever you kill an enemy, its score component is going to be added to your total score and then drawn on the screen. We have a lifespan component. The lifespan component is going to store the total lifespan that the entity started with. So if the entity should live for, let's say, 3 seconds, then this will be 180 frames. And then the remaining variable here, that's how much you have left of that total 180. So if it's been 2 seconds of the 180, so then there'll be 60 frames remaining in a 60 frame per second game. And you're going to use this, the current time remaining and the total lifespan, to calculate the alpha channel so that it fades out smoothly from completely opaque to completely transparent right as the lifespan ends. And then we also have an input component. And basically the input component is going to store all of the controls that we want to control an entity with. So in this assignment, only the player is going to have an input component. And then when we go through our user input system, the user input system is going to set these booleans here. So if it's moving up, it's going to detect you hit the W key, so set up to true. And then in the movement system, we're going to be reading the input component and actually doing the math for the movement. So that's how that's going to work. A lot of this stuff is going to change for assignment 3. We're going to make it a little bit more abstract, like the input especially, but that's what we're going with for assignment 2. The entity class, we've seen this ad nauseum now. We covered a lecture or 2 about this, so I won't go into all those details. But again, just an entity is a game object. It stores a component tuple. The tag is the type. Active is whether or not it's alive or dead. I'm not sure if it's called alive or active. We'll see that when we get to the code. The ID is the unique identifier. So this is the entity class that we're going with. The entity manager class is the exact same that we saw in the last lecture. So this is the factory class. It implements this delayed entity add that we talked about and delayed entity removal so that we don't have iterator invalidation. And it also stores this secondary data structure, which is the map from tags to vectors of entities so that we can do things like get all the bullets or whatever. And if we wanted to, we could do other bookkeeping and memory management in here, but we're just not going to do that for assignment 2. The game class is going to store more variables than this, but I couldn't fit them all here. And these are the ones that are really important, sorry. So for example, it's going to store the SF window, it's going to store the entity manager, whether or not the game is running, whether or not it's paused, etc. It's going to have all of these systems down here. So we're going to have a movement system, a user input system, an enemy spawner system, collision system, etc. So this is the top level game object. It's going to hold all of the data relevant to the game and all of the system functions as well. For future assignments, I have a slide about this, so I'll talk about this then. And all of the gameplay code is going to be implemented via systems inside this game class. We also have the vec2 class, which is a skeleton code that you have to implement. So I've given you all the functions that I think you should want, and then you just implement the code for those. And so this is the 2D math structure. And the only thing that's different that we haven't talked about yet is that this class is actually templated. So before, when I talked about the vec2 class, I just stored floats for x and y. But for example, what if we wanted to have a vec2 of ints, or a vec2 of doubles, right? Or a vec2 of chars, or any other data type? So what I've done is I've actually just templated this, and none of the math changes. It's all the same code. It's just that now we could have a vec2 of ints or a vec2 of floats if we wanted to. But in this assignment, we'll just be using floats. And so what I've done, instead of you needing to type vec2 float every time you want to create a vec2, I've got a using vec2f equals vec2 of float. So if you want to create a vec2 of floats, you just say vec2f v and then whatever the parameters are. And I'll get into more details about that when we get to that part. So what can this game engine do? It can create game objects as entity instances. It can add components to those entities. It can implement all the gameplay mechanics via systems. And it can also handle all of our user input. It can pause the gameplay. It can exit the game. And it can initialize all the variables that we need. And it can load them from a configuration file as well. So this is what we're doing for assignment 2. I don't want to throw too much at you. But what are the limitations that we will see in future assignments? This game engine, this iteration, can only display one game scene. So you just launch the game and you're playing the game. There's no menu, there's no inventory or anything like that. It's pretty basic. Currently, we cannot load textures or sound assets into this game. We are just drawing the basic SFML shapes. And so you could load textures and sounds, but what I mean is this game engine architecture that we are showing doesn't have that capability built in. Whereas in assignment 3, we'll be loading textures, talking about best practices for that, etc. We can't display any textured animations, so we couldn't have like Super Mario running around in this game nicely animated, but we will for assignment 3. It doesn't have any menu. I don't know why I said /interface because it literally does have an interface, so apologies for that. And just again, what do I mean by it can only display one scene? I've talked about this before. There are different types of scenes within a game, or at least that's what I call it. You might call it modes or types of gameplay or whatever. We'll get into that with assignment 3, but we're not doing that with assignment 2. And before I get into the README file, just last year I actually just opened up Paint and did this like in real time, but I figured why not put it in the slides so I make sure I'm doing it right. This assignment, as you saw, is going to be using a bunch of circles. In fact, all of the objects, regardless if they are triangles or pentagons or whatever, they are all actually implemented as circles. So, of course, circles can't be drawn to the screen, true mathematical circles. We can't draw an infinite number of points to make a true circle. And so we draw some number of points on the screen in order to make it look circle-y enough, right? And so some finite amount of points to our eyes will look like a circle. And so we draw enough of them on the screen. So for example, if I were to create an SF circle shape, C, that's going to be the name of our variable here, with a given radius and a point count. So these are the parameters that go into that. I'm sure you're all familiar with that from assignment 1. And if I had p equal to 128, we get a pretty smooth circle here. That's good enough for all of our purposes. But what if I, instead of that, 128, I set my point count to 3? Well, then I literally get a triangle, because these points are co-circular. They are all on the same circle. It's just that we're trying to draw a circle with 3 lines. If I set that to 6, then I would get something like this. Okay? Now, something that you're going to have to do in assignment 2 is read from a config file different parameters of how we want to draw this quote-unquote circle. So one of those is going to be the outline thickness. So by default, the outline thickness might be 1 or something like that. But if I set the outline thickness to something bigger, then you'll get something like this in the game. So it kind of draws a border around the shape if you want to look like that. If I want to change the color of that, I can set the outline color. So here I set the outline color to red. And if I want to have a color in the middle, I would set the fill color. And so if I do this, this is approximately what your shape will look like in SFML. I did it in PowerPoint graphics, of course, but it should look approximately the same. One other little trick is that if you set the outline thickness to 0, you basically have no outline, right? So there's no thickness. So if you ever want it to have no outline, you can do that as well. Something else that is of importance for this assignment is where on the screen the objects actually get drawn. And I know some people came to my office hours and we talked about this a little bit. But in SFML, we talk about the origin of a shape that we draw. So the origin is where it actually gets drawn in the screen. And by default, every SFML shape, the origin is in the top left corner of its bounding rectangle. So if you drew a circle at position 0, 0 in SFML, then the top left of this imaginary bounding box is where the circle would actually be. You might think that it would draw the middle of the circle in the top left corner, so you'd only be seeing like a quarter of the circle, but no, by default, it's in the top left. So that's what we're going to have to change in this assignment. It'll be done for you, but I want you to know about this. So what we have to do is we have to bring the origin of this shape object down to the middle, so that whenever we go to draw the circle, now it's the middle of the circle that gets drawn at that location rather than the top left. And because we're doing collisions with circles, it's going to be a lot easier to do the math from the middle of the circle, so we can just use the radius rather than having to try and do all the math from the top left corner. So what we do is we set the origin. And where do we set the origin? Well, that's simply we go over in x by the radius of the circle, and we go down by the radius of the circle. So this will actually be done for you, and I'll show that in the code in the constructor of the circle shape component. And so you won't actually have to do this, it's all done behind the scenes. But just keep in mind that this makes our collision math much, much easier. All of our collisions in this assignment are going to be circle collisions, and we talked about the math for that last time, so I'm not going to go into the math, but what I did want to talk about very briefly is that the shape collisions, because they are being represented by circles, you might say, okay, how am I going to compute whether or not a triangle is intersecting a hexagon, right? Like, do I have to take all of the different sides and compute those sides and see if the lines are intersecting? Nope. We're just going to approximate those with circles. And for all gameplay purposes, it's going to look fine, right? It is an approximation. And so we're going to be using the bounding circles of these shapes in order to do the collisions. And if we look, no, these shapes aren't actually touching, but for the purposes of our gameplay, they are touching. Why? Because their circles are touching. Okay, so yes, this will actually be a collision in our game, and if we slowed it down and we zoomed into the pixel level, yes, we could see this error, but it's so much faster and so much nicer to do the math this way. And you'll find when you get into a lot of game programming, you stop at good enough, right? Because this isn't going to make a difference for any sort of gameplay. Yeah.
So if you change the thickness of those shapes, does that also change the bounding box?
It turns out that, and that's a great question, what we are going to do is we're going to have two separate things. One is the radius of the shape that gets drawn, but we'll have a separate component for collisions that has its own radius, right? So that way, let's say we wanted to turn the difficulty of the game down. We could keep the player being drawn the same size, but shrink the collision radius, so we could actually allow some overlap with games. And later on, when I talk about axis-aligned bounding boxes, I'll have some examples from real games of this. Like, the reason, if you've ever seen like a speed run of the original Super Mario Brothers, it looks like they're jumping through the piranha plants, and that's because the bounding boxes of the collisions are way smaller than the graphics that get drawn. And so we're going to keep those two separate variables exactly for that purpose. We can set the collision radius to whatever we want. And the last note on some extra math that you'll have to do for this assignment that I haven't explicitly included is, let's say this is one of my large enemies. Whenever it collides with the player or with a bullet, you saw that, so for example, this is a pentagon, so it has 5 sides. You will delete or destroy this entity. You will spawn 5 pentagons of half the radius of the original one, and they will explode outwards in equiradial angles. So what do I mean by that? So you're going to take this shape, you're going to compute whatever this angle is, right? So if it's 5, it's just 360 degrees divided by 5. What is that, 1? No. I can't do that in my head. So what's that? 72, perfect. You have a calculator, I don't. So every 72 degrees, so you'll just create a little loop that says for 0 up to 360 by this angle step, spawn an enemy, and you have to give it a velocity that points in these directions. Okay, so you have to figure out that math. I've given you all the math right? Like how to go from angle and speed to vector update. I've done that. You just have to actually implement it. So here's what it looks like. Hopefully this works because I spent a bit of time doing this in PowerPoint for no reason. So we have an enemy, and then we're going to spawn 5 enemies right on top of each other, and they'll go like this. Ah, it worked. Okay, perfect. So the other thing to keep in mind is that as these small enemies are going to be given a lifespan that is in the configuration file, and that lifespan will tick down, and as it ticks down, you have to figure out, okay, how much of that time is remaining as a percentage of its total lifespan, and then set the alpha channel of the color of the small enemy to match so that it goes from completely opaque to completely transparent. And then what happens is, on the frame that the lifespan is over, the thing gets destroyed, but it's being destroyed right as it becomes completely transparent, and so it looks smooth, right? Okay, so those are the slides. I'll put that PDF up there on Brightspace for you so you can refer to that. But what I want to do now is go, as always, through the code. So, not the code, but I'll go through the README file first. So let me make this as big as I can. That's probably as big as I can make it. The top of the assignment here is basically the same. It just says to zip and submit the source directory instead of just the main.cpp file. So still, you know, if you're working with a partner, include all the people's names at the top of main.cpp so that I and the TA know who is in your group. Okay, program specification. I'll read through all of this just to make sure I haven't made any mistakes. So in this assignment, you'll be writing the game that was presented in class for assignment 2. That's the Geometry Wars. So I have different headings here. So we'll talk about the player first. So the player is represented by a shape which is defined in the configuration file. You're about to hear me say which is defined in the configuration file about 20 times, but I'll go to the config file once we get to the bottom of this rather than go back and forth, back and forth. The player must spawn in the center of the screen at the beginning of the game and after it dies, meaning when it collides with an enemy. The player moves at a speed s, read from the configuration file in these directions. The W key is up, left is A, down is S, and right is D. Note, this is a tricky one, and it loses probably most people marks, so I didn't have this specifically in the config file last year, but I put it in now. Be careful to set the speed of the player appropriately. If the player is moving diagonally, it should not be traveling at speed s in both axes, but its total speed along the diagonal should be s. So for example, let's say my speed is 5 and I hold up. If I hold up, then I'm traveling 5 pixels per frame. Fine. If I also hold right, then I would be traveling 5 pixels to the right. But going 5 pixels per frame up and 5 pixels per frame right, that's a total of more than 5, right? It's about square root of 2 times 5. And so what you have to do is make sure that you take that movement vector and scale it so that the diagonal speed is actually 5. And if you've ever played any game, especially older first-person shooter games, this is the reason why strafe running is faster than running straight. It's because the programmers didn't do this, and so whenever you're running forward and you strafe, it's adding both of those speeds. So for some games, you might say, okay, well that actually became an interesting gameplay mechanic, right? And it was like an extra level of skill that professional players could have over normal players, is like bunny hopping and strafe running and wall running and all this sort of crazy stuff. But we're going to be good programmers, and we're going to not do that. So there'll be a couple of marks lost if you don't do this. The player is confined to move only within the bounds of the window. So I didn't explicitly show that in the demo, but if you moved all the way over, it shouldn't just keep going. It should stop, like in assignment 1. The player will shoot a bullet toward the mouse pointer when the left mouse button is clicked. The speed, size, and lifespan of the bullets are read from the configuration file. Next is a special ability. You are free, actually, you're not free to come up with. You are free to decide what it is, but you must come up with a special ability to get full marks for the assignment. And that's fired by the player when the right mouse button is clicked. Here are some constraints that I've placed on that. You can do whatever you want with the special weapon, but it must contain this functionality. But it can contain more if you want to. Multiple entities must be spawned by the special weapon. So you saw me just fire out in like a radius with a bunch of bullets. You can't do that. It must be more complex than that. Entities have some unique graphic associated with them. A unique gameplay mechanic is introduced via a new component. So you're actually going to have to go into the components file, create a new component, and then add that to the entity class, and then you'll use that component somehow. Just be aware that over here in source entity, up at the top here, these are all the entities that are contained in the component tuple, or the components that are contained in the component tuple. Say that 3 times fast. And so if you come up with a new component, let's say I've made the Dave component, whatever you call that class, you'll just have to add that there. And because if you don't add it there, it's not in the tuple. So when you go to like get or add that type of component, you'll have a weird compiler error. It turns out that compiler errors that are caused by template mismatches are the worst type of compiler errors. So make sure you add that there. Really? Here we go. No, that's Mark's. Read me. Okay. A cooldown timer must be implemented for the special weapon. So this is one of those do as I say, not what I do. So in the solution, you can just spam click the special weapon however you want. You must implement some sort of limit on that special weapon. It doesn't necessarily have to be just a timer, but it can be just a timer. So for example, you can't click it more than once per second or something like that. That has to be that has to also be visible somehow. So let me do this. The cooldown mechanism must be visible to the player. Okay, not in IMGUI. So if IMGUI was turned off, the player could see that. So for example, you could have a little bar that like ticks down to when you can next fire it. One special weapon that I saw a couple of years ago that was really nice was like a flamethrower, and it shot out a bunch of orange things that made it look like a flame, and then it had fuel. So the fuel was gotten back by killing enemies. So that is also fine if you want to implement something like that. Just something that makes it not infinitely spammable in order to kill everything on the screen. All right. So that's the special weapon. That has to be done. Oh, and the properties of the special weapon are not in the configuration file. So even though if you were making your own game, you should put everything you can should always be in config files so that like the game designers and stuff could come in and tweak it. Because you're only submitting the source directory and you're not submitting the config file, it's okay for you to hard code all the properties of your special weapon. Okay? Just make sure that they're all coded with the 60 frames per second in mind. Enemies. Enemies will spawn in a random location on the screen every X frames, where X is defined in the config file. Enemies must not overlap the sides of the screen at the time of spawn. So that just means that like you can't have an enemy that like spawns halfway into the side of the screen. It must be completely within the bounds of the screen. So you'll have to take, like for example, you'll have to compute the left, top, bottom, and right bounds. And so you take each of the top, left, bottom, and right of the screen and you just subtract the radius of the enemies and you should be fine, right? You just spawn things in there. So if the radius of an enemy is 100 pixels, you would never spawn an enemy to the left of x equal 100, okay? Enemy shapes have random number of vertices between a given minimum and maximum, which is specified in the config file. So that's probably going to be like between 3 and 8. So you'll be spawning triangles to octagons, right? And that's going to be generated randomly. Each shape radius will be specified in the configuration file, or sorry, enemy shape radius. Each of the enemies will have the same radius, and each of the smaller enemies will have half of the radius of the big enemies. Enemies will be given a random color upon spawning. So whenever you set the fill color of the enemy, each of the RGB components, you're going to do a rand mod 255 to get a value between 0 and 255 for each of those. Enemies will be given a random speed upon spawning between a minimum and maximum value in the configuration file. When an enemy reaches the edge of the windows, it should bounce off in the opposite direction. So that's almost the same thing that happened in assignment 1. And here's probably the most complicated part of that. This is the death of the enemy and the spawning of the small enemies. So when larger enemies collide with a bullet or the player, they are destroyed. And n smaller enemies spawn in its place, where n is the number of vertices of the original enemy. Each small enemy must have the same number of vertices and color of the original enemy. These small entities travel outwards at angles of fixed intervals equal to 360 degrees divided by the number of vertices. For example, if the original enemy had 6 sides, the 6 smaller enemies will travel outward in equal intervals of 60 degrees. And I have not specified this in the config file, and so just give those smaller enemies some sort of reasonable speed for gameplay purposes. Don't make them just instantly destroy the player. The score. Each time an enemy spawns, it will be given a score component of n times 100, where n is the number of vertices that it has. Small enemies get double this value. If a bullet kills an enemy, the game score is increased by the score component of the enemy killed. The score should be displayed with the font specified by the config file in the top left corner of the screen. And I'm not sure if I said this anywhere, but sorry, I don't mean to give you seasickness here. Score, just in case I haven't said it, small enemies should be given double the score of its larger enemy. Okay, so the small enemies, if it has 5 sides, will have 1,000 points instead of 500 points. Drawing. In the rendering systems, all entities should be given a slow rotation, which makes the game look a little nicer. What does that mean? Well, when I run the game, you can see that everything is just rotating a little bit. And so that actually makes the game look a lot nicer than if it didn't have that. Let me turn off the spawning, and I'll go back to here. Any special effects that you create which do not alter gameplay can be added for up to 5% bonus marks on the assignment. Note that the assignment cannot go over 100% total marks, but the 5% bonus can overwrite any other marks that you lost. So for example, one person last year, whenever a bullet hit an enemy, had like a screen shake effect, and like everything shook around for a second. So that would give you the 5% if you did something like that. Any entity with a lifespan that is still alive, so this is bullets and small enemies, should have its color alpha channel set to a ratio depending on how long it has left to live. For example, if an entity has an 80 frame lifespan and 25 frames remaining, the alpha channel should be set to 25 divided by 80 times 255. The alpha should go from 255 when it first spawned to 0 on the last frame when it's alive. Can anyone tell me why I put that float there? Why did I convert that 25 to a float? Yeah?
Wouldn't otherwise 25 over 80 would just be 0?
Yeah, so if I don't make that a float, then we are doing integer division, and 25 divided by 80 with integers is 0, right? So I want this to be like 0.3 or whatever it happens to be, and then multiply that by 255. Okay. The GUI. You must construct a GUI using IamGUI, which has the following functionality. The GUI must display options to turn off each system independently. You don't have to, let me just write this in here, with the exception of the rendering and GUI systems, because that just throws everything. If you turn off all the rendering, how are you going to click it back on? The GUI must, I just said that. For each entity in the game, the GUI must list the ID, tag, and position of that entity. You must display a list of all entities as well as a list of entities by their tag. So I don't think I showed all of that actually. So over in the Entity Manager, here's the entities by tag, where I list all the entities by the tag, and then down here, I also have all the entities in the game. So if I go back and I spawn a few things, you'll see all of them down here. Just keep in mind, I'm about to mention the part where you can delete entities. Just don't delete the player, because currently my solution has no backup. If you just delete the player, the player has no respawn mechanism unless it interacts with an entity, and if it doesn't exist, it can't interact. So don't worry about the case of deleting the player. Okay, you don't have to fix that. But if you do, it's fine, but we're not grading that.
So
Yep.
the small enemies, they just have a lifespan?
Yep. They have a lifespan, but they still should appear here. But when they...
Kill the player?
What's that?
The small enemies can kill the
Yeah, they still can collide with the player, no matter, like, right up until the point where they die. So even if they're half transparent, that doesn't really mean anything. We don't have hit points or anything like that here. It's just a basic collision. So if they collide with the player, they kill them. You must also have some way of destroying an entity by interacting with the UI element associated with it. Now let me just mention that really quickly, because over here, let me turn off the movement and then spawn some stuff. Over here, so the enemies, I have all of these buttons here associated with each enemy. And now I've colored them to match the enemy. You don't have to do that. It's fine not to do that. I just wanted to show you sort of what was possible. So here it lists the tag, it lists the ID, and it lists the position of that entity. And let's say I click this one, then it gets deleted. I don't know why this thing is popping up, but if it does, it's fine because my solution does it. The only thing you have to be aware of here is the thing I mentioned in the IMGUI tutorial, which is if all of these buttons have the same text that is displayed, then you're going to have to put the double pound sign and something unique after it. So what I did, I believe, is that I named each one D, pound, pound, and then the ID, so that you know each of the buttons has a unique name. You must be able to change the enemy spawn interval through the UI. I've done that with a slider. You can do that however you want. You must be able to manually spawn enemies in some way through the GUI. You must develop the GUI in a way that it contains this functionality, but it must be easily able... What am I even saying? You must develop the GUI in any way that contains this functionality. So yeah, you can do it in any way that lets you do this. It doesn't have to look like exactly how I've done it, and I've just phrased it in a terrible way there. Oh, miscellaneous, the P key should pause the game and the escape key should close the game. So over here, it looks like the game is paused, but it's not. Why? Because if I were to kill this and then turn off movement, the lifespan would still be going. But let me just show you. So I'm playing the game, and I've killed some stuff, and then I pause the game. Hitting P pauses everything. Now, it's still rotating. I've just given it that, like, it looks kind of cool if it's still rotating. Do that. So everything should be paused except the rotation of the entities. So here, I can't move, I can't do anything, the game is paused. I probably should put up something on the screen that says it's paused so you don't think the game is crashed. But if I hit P again, then it keeps going. And the escape key closes it. All right, the config file. The configuration file will have one line each specifying the window size, font, format, etc. I'll go through this rather quickly because you can read it all. The window is going to be the width, height, the frame limit, and the whether or not it's full screen. So if we go over to the config file, that's in the bin directory, config. Yeah, so over here in this version, I've said the window is 1920 by 1080. It should have a frame limit of 60, and it is not full screen. I'm not going to demonstrate full screen here because it interferes with the OBS capture, and I don't want to mess up the lecture capture. The next thing is the font, and the font, I believe, is exactly the same as it was in assignment 1. So it's the font file, then the size, and the RGB. The player specification, this is where things start to get a little bit complicated, but it's not too bad. So it's going to be player, then SR, which is the shape radius, that's going to be an integer. The collision radius, which is another integer. The speed, that's the speed that the player should move when you hold the direction keys. Then you are given the fill color RGB, the outline color RGB, the outline thickness, and the number of shape vertices. Okay, so if we go look at config, that's what this is. The shape radius and the collision radius and whatever else I just said, which I'm not going to read off again. I want to have more time to go through the code. The enemy is identical to the shape to the player up until this point, but then you have the min and max vertices that you should spawn in between, as well as the lifespan of the small enemies and the spawn interval. So if the spawn interval is 60, then it's once per second. The bullet specification down here is, again, everything is the same except the lifespan, I believe. So yeah, I'm sure you can all figure that out. And just to show that it does work, let's say the player is going to have, let me just add a 0 there and then launch the solution again. Yeah. So being able to change all that stuff, it looks kind of funny, but it's nice to have all of those things in a config file rather than hard-coded for that reason. Assignment hints. All right, so I recommend doing the assignment in the following order because it does everything in the order that it should be done, and nothing you're doing at any given time needs something else to be done. So first, implement the vec2 class, because the vec2 class is used for everything, right? So if you don't implement that, nothing will work. So absolutely do this first. And if I come down here to the vec2 class, we'll just step through this really quickly. I've got my templated vec2 class, so whatever type name we specify this with, if it's float or int, that will be the type of the internal x and y. I've got a default constructor here which does nothing, so if you just default construct a vec2, it's going to be 0 and 0. I've got the constructor for you here that takes in the x and y and sets the x and y to that. I've also given you these here, which are constructors based on the SFML vectors, so it will automatically be able to convert between SFML vectors and vec2f. So you will be able to set the position of things based on the vec2f, which just makes things nice. So I've done all that for you, but everything else, all the plus, minus, divide, times, add, plus, equals, length, normalize, distance to another thing, all of those you have to implement. So if by default you come in and you try and to add two vectors, well, it's going to return 0, 0, no matter what you do until you modify this file. So the very first thing you do, absolutely, is come modify this. And then, before you do anything else, trust me, go to main.cpp, and up here, test your vec2 class. I've seen people in this 4th year computer science class, and this is not a knock on students, it is a knock on us as professors because we haven't taught you. People will try and write everything before they run it the first time. And then it's like, where's my error? Well, at every numbered step of this hints part, the recommended order, test what you have done before you go to the next step. So in here, do what I did in that live coding session. Make two vec2s of different types, add them together, multiply them by something, try and get the length of it, print those values out. Make sure that that vec2 class works. Because if it doesn't, and then you go implement everything else, and it doesn't work, then you might say, well, where is my error in my code? Why doesn't my collision work? Well, it's because you did something wrong in the vec2 class. So make sure you test that before you do anything else. All right, at some point, implement entity manager remove dead entities. You can absolutely do most of this assignment, like the spawning, the attacking, the everything, without actually removing entities from the entity manager. But just keep in mind that all the entity manager has been implemented for you. So down here, the update function is all done. Adding entities, getting entities by tag, everything is done for you. Now I say it's done for you, but in the update function, I call this function, which is remove dead entities. That function is up here. I pass in an entity vec reference, and you have to remove all the entities from that vector that are no longer alive, okay? And please don't just go to ChatGPT and say, how do I remove based on a Boolean flag from a vector? Give that a go first, right? If you can't get it, come to the office hours. I would love to help you with this because I think this is just a nice little life lesson in programming is trying to implement this. Once you're done with this, then all of the entity stuff will work. So just keep in mind, by default, the entity manager lets you add stuff and get stuff, but it won't actually remove stuff until you've implemented that function, okay? So implement that whenever you feel necessary. It will actually be difficult to test that until you've done some of the other stuff. Like until you've added stuff to it, it's hard to test the removal of it. I just wanted to put it up on the top. Then implement some of the basics of the game class. So first, construct a player using the spawn player function. Oh, you know what? I haven't even shown you what I've given you. So if I come here, make clean, make run. So this is what you get by default. It's just a hard-coded circle rotating and moving down and to the right. So that's what you get by default. And you have to build on that. So I'm going to close it. Construct a player entity using the spawn player function. So if we go over, I'll read through all of this and then I'll open the game class and I'll go through all of that code. So I recommend spawning a player first because everything hinges on the player. Then implement the basic drawing of entities using the game's render function. So what I've given you in the render function is literally only drawing the player. What you have to do for the render function is just create a loop over all entities and do the thing I did for the player. So I'll get to that. Then construct some entities using the spawn enemy function. Then construct a bullet using the spawn bullet function. Then I would implement some player movement in the user input and the movement systems. Then do collisions in the collision system and entity destroy. So entity destroy, if two things have collided, destroy them, and then the entity manager remove dead entities. Implement the rest of the game's functionality, including the config file reading, and then implement the GUI functionality. However, I find that actually having the GUI is good for debugging the rest of the game. So do the GUI whenever you want, but you can do the whole assignment without having the user interface if you want to. I just find it's kind of nice for catching those edge cases. So let's go over to, so I've compiled a bunch of stuff here, so I'm just going to make clean real quick to get rid of that. Then over here, I'll first go through components. So in my C++ video, I talk about separating class files into header files and CPP files. That's absolutely fine. However, for simplicity's sake, you can also combine those two into a single file. And if you do combine them into a single file, the typical naming structure for that is .hpp. So instead of having an H and a CPP, you can put all the code in the header file .hpp. You can't always do that. This is a nightmare if you have things like cyclical references. Like if you have class A that uses class B and then class B also uses class A, it turns out it's nearly impossible to resolve cyclic dependencies if you have everything in the header file. Also, when you have everything in the header file, every time you recompile, all of those header files get recompiled every time. So you have a very large project with thousands of classes and thousands of files. You'll be recompiling the whole thing every time instead of just recompiling all the .cpp files, which have changed, and then it gets relinked. So for very large projects, don't do this. I'm just doing it so you don't have 12 files here, you only have 6 files instead. But I just wanted to explain that. So components.hpp stores all of our components. And rather than, I talked about this last time, but rather than have to have an exists variable in every single component, I just have this base class component and everything inherits from that. And so every single one of these classes also have this exists variable. So the transform component has the position, velocity, and the angle. Each of our components is going to have a default constructor as well as a convenience constructor that lets us pass in some variables. So the constructor for the transform takes in the position, the velocity, and the angle. The shape component, there's a default constructor here as well as a shape, another constructor that takes in radius, the number of points, the fill color, the outline color, and the thickness of the outline. And what that does is it constructs the circle and sets all of those properties for you. So where I said that components are pure data, I'm lying a little bit here, but I'm just setting up the properties of that shape. I'm not actually doing any logic here, except for you could argue that this is some logic where I actually do set the origin to the middle, right? So that's the only logic I'm ever doing in any of these constructors, is just putting the data in the correct place. Next, we have the collision component. That is just a radius that we're using for collision. The score is just an integer. The lifespan has a lifespan. That is the total lifespan. and remaining is how much of it is remaining. So let's say I have a lifespan of 60, so that would be 1 second. So this lifespan variable will always remain at 60. Remaining gets set to 60 at the beginning, but then the lifespan system every frame will take 1 away from remaining, and then when we finally hit 0 on remaining, that's when we destroy our entity. And then input just basically has one variable for each type of input that we could possibly issue to a player, and that's just a Boolean variable. And then the movement system is going to take that and do something with it. All right, next we have the entity class. We've already gone over the entity class, but just again to drive home, if you do create your own component, which you should because that's part of the marks, you do have to add it here. And for components, all you would have to do is come in here, take this, copy it, paste it, and then change the name here, change the name here, change the name here, and then of course the logic of the constructors and the variables or whatever, right? So you would just make your own component there, and then you would come over to the entity and add it. Add it to here. Make sure of that because that's a top problem that I have every year. Someone forgets to do that, and there's a bunch of weird compiler errors. So I'll just delete that. The next file is the entity manager. I've already gone over that. Let me go into game.cpp, game.h and game.cpp. The reason I've separated game into h and cpp is you're about to see why now, and it's for convenience of being able to see an overview of the whole class at once. This is where header files really shine, is you can see a list of all the variables that you need and a list of all the functions without all of their implementation details cluttering it up, right? So, as we saw from the configuration files, the first thing I want to go over is what in the hell is this? Well, you're going to have to store a ton of different variables from the configuration file, and what I've done is just made some structs for you. So a struct in C++ is essentially a class where everything is public. And so in here, I've made a player config struct and an enemy config struct. And down here, I've made variables for you in the game class. So whenever you are reading from the config file, if you're reading in the shape radius for the player, you can say mplayerconfig.sr, and you can read the variables straight into that. So all of those are there. You don't need to create variables for all of that. We have the window, we have the entity manager, the fonts and the text, the score, the current frame, the last enemy spawn time. Because we have to spawn enemies every so many frames, it's good to have a variable to say when was the last time we spawned an enemy, right? So your logic for the enemy spawning system is going to spawn an enemy and then say, okay, when every frame it checks, when was the last time I spawned an enemy? Was that greater to or equal, is the difference between the current frame and the last time I spawned it, say that's 50, right? So it was 50 frames ago. I'm supposed to spawn an enemy every 60 frames. 50 isn't 60 yet, so I don't spawn anything on this frame. But if it is greater than or equal to, then you would spawn an enemy and then set this equal to that, right? So that's just one way that you can implement that. And the paused variable is here whether or not the game is supposed to be paused right now. And lastly, we'll have a look at the actual game class where you're going to be spending most of your time. So I'll just go from top to bottom. So the game class takes in the name of a config file, okay? If I go over to main.cpp, we've got this really clean main.cpp, which just says I've got a game, I give it a variable name, I pass in a config file, and I run, right? So that's super clean. All of the game's data is stored within that game object. It's really nice, and so that's how we run it. So over here, the only thing the constructor does is call the init function. So the init function is going to take in the path of the config file, and right here is where you would write all of the code to go through the config files and read in like the window size, the player size, the shape radius, all that kind of stuff would just go there. Another quick note is that if you want to, you can absolutely add new functions to this file. Like if you want to have a read config file function, that's fine. But just don't add any files to this to this project, okay? So you can't have any new files, but you can absolutely make new functions if you want to. Then what I do is I create the window for you. This is hard-coded right now, but this should read in those variables that you read in from the config file. This set key repeated enabled, that is something I figured out pretty quick that's necessary. So if I hold down the W key, on some operating systems, that will repeatedly press the W key. But we don't want that. We want there to be one press event and one release event. So SFML has an option of which one it should be. Should I fire the press event every frame when the thing is held down, or should I not? And this means not, and that's what we want. So that's why that's there. Then I set the frame limit, and again, this should be set to whatever's in the config file. I init SFML, and I init IMGUI, and the very first thing that happens is the spawn player function is called. Okay. In this assignment, the entity manager stores all the entities, and you're going to be referring to the player entity a lot, right? So what I've done here is I've just written you a little function called player, and what this does is it gets the player entity right from the entity manager. So there should only ever be one player at a time. Keep in mind that a little tricky thing is, so you spawn the player, and then the player might collide with another enemy. And so the player should be put back to the middle of the screen. But if all you do is call spawn player again, you're actually creating a second player. And so for that split second between frames, there are actually going to be two player objects. So one thing that I did in the solution is say, okay, in my spawn player function, which spawns it back at the middle, instead of actually deleting the player and creating a new one, I just set the current player back to the middle. So check to see if there is a player. If there isn't a player, spawn a new one. But if a player already exists, then just set them back to the start. So that's what my spawn player does. This is the run function. So this is just our main loop that calls all of our things. So the entity manager gets updated. This is a required thing to make sure that IMGUI runs correctly. Then our user input, then all of our gameplay systems, and then our rendering. Okay, so that's all of that. You will have to implement some changes here based on the pausing functionality. So if it's paused, or if it's not paused, do these things, but certain other things should always happen, right? It should always be rendering, for example. You never want to not draw it to the screen, but certain functions should be turned off if the game is paused, like movement, lifespan, etc. So you're going to have to put that in there somewhere, and then keep track of the frame. I don't know why I have this set paused function there, because you can literally just set the variable, so I'm just going to delete that. Spawn player. So spawn player is the function that spawns the player, obviously. I have put in some skeleton or example code here for you. So what my example code does is it tells the entity manager, hey, add a new player. Okay, so it creates an entity, adds it to the entity manager. Then I hard code it to spawn at position 200, 200, so near the top left of the screen, with a velocity of 1 and 1. So this means every second it's going to move 60 frames because it's 1 per frame. And then this is the angle that it starts with, okay, which is 0. And the angle, just set it to 0, that's fine. I'm going to add a shape component to the player. It's going to be hard-coded to be 32 shape radius with an 8 collision radius. And it's going to have these colors. And then I add an input component to it. So that's what you're going to do. You're going to, instead of doing this hard-coded stuff, you have already read all the properties from the config file up in init. So you're going to spawn your player with all of those things. So for example, here, where it spawns it at this hard-coded location, you're going to have to figure out the middle of the screen. So you can use window.getSize divided by 2.x or whatever. Spawn it in the middle of the screen. Give it no velocity to start, because your velocity is going to be determined by your input, not by just moving it around. Then down here, instead of 32, this is going to be like mplayerconfig .sr, for example. right? So that's the shape radius, that's how you pass it in there. So that's spawn player. Just make sure you do that with all the stuff from the config file. This is the spawn enemy function. So this gets called by the enemy spawning function. So there's a function that like checks every frame, but this is the actual function that spawns an enemy. So what you have to do is just do the things I said. So create a new enemy in the same way that you were creating a player, but give it an enemy tag, and then give it all the properties that you read in from the config file. Spawning small enemies. This one takes in a parameter. That parameter should be the enemy that died in order to spawn those small enemies. So because the radius, like the size of this is going to be the original enemy over 2, you can get the properties of that entity here. So it would be just like entity get c transform dot whatever, then you know that's the property of the, or it would be the shape. So c shape and the size would be there. So you'd get those properties. When we create a smaller entity, we have to read the values. So spawn a number of small entities equal to the vertices of the original entity. That would be the shape component's get point count. So just remember that if you want to get the actual shape variable, this is a little bit tricky at first, there is a C shape component, but then inside that is the actual circle, right? So I just want to show this. So it would be like E, that's the entity that died to spawn this, get C shape dot circle dot get point count. So that would be the number of sides of the circle that spawned this. And then you can also get its fill color and set the fill color of the small one to that, etc. So you have to read the parent properties of that. And they're worth double the points of the original one. Spawn bullet, this takes in 2 parameters. The first parameter is the entity that is spawning the bullets, which is typically, for this assignment, going to be the player. And the target, which is going to be where you clicked with the mouse. So this is going to, you're going to go back to that 2D vector math slide and figure out how do I set the velocity of the bullet so that it will travel toward where I clicked at the given speed. Spawn special weapon, this is going to be passed in the entity that spawns the special weapon, which in this case will always be the player. So do whatever you want in here for the special weapon. The movement system. The movement system, essentially, for this game, is incredibly easy. You're just adding the velocity of each entity to its position. Now here, what I've done is I've gotten, something you're probably going to want to do a lot, is in order to save having to type this every time you want to get the transform, is to set up a variable that points to that transform. You can also just call it t. That's what I do sometimes. So it's a lot easier to just say t dot whatever than to say player get c transform. So this t, that's the transform. And keep in mind, this was, I made a D2L post about this. What some of you will probably do, and what I've done in the past, and then bang my head against the wall, is do this. If you do this, it makes a copy of the transform object. And no matter how you modify that object, nothing will actually change in your original entity because it's not pointing to the thing that lives in the entity. It's this copy that you created on the stack here. So make sure this is a reference. And the reason I didn't do the following, so what you can do is say t.pos plus equals t.velocity. Why didn't I do that? Why did I piecewise add the x and y here? Yep.
It's because vec2 isn't implemented yet.
Exactly. So it would just return 0 if I had done that, right? So after you have implemented vec2, you can absolutely just type stuff like this. And because this is only doing it for the player, you just have to say, hey, for each entity, I'll just show you. The way you would use that, for auto e in m entities dot get entities. Boom. Why can I say auto e here without the reference? The reason is because it's a shared pointer. So it's already pointing to the thing we want it to point to. You absolutely can do this, and some people recommend it. I personally, if I'm using a shared pointer, I want to use it as a shared pointer with properly reference counted things. So that's why I do this, but auto reference e is still fine as well. So that's what you would do, and you would just update that e instead of just the player. The lifespan system, I've already explained that a couple of times. You just say, hey, loop over all the entities. If this entity has a lifespan, then subtract 1 from remaining, and then check to see if it's at 0. If it is, destroy it. And then everything with a lifespan will be handled. Also, set its alpha channel, like I said before. The collision code, I've put in a little bit of sample code here for you. Everywhere there has to be a collision, so between the player and the enemies, as well as between the bullets and the enemies, and the player and the walls. So those are the 3 cases that you have to do here. So for example, if I want to get all the bullets, and for each bullet, check all the enemies, I've put in the loops here for you, but I haven't done the actual logic. So in the logic here, that's where you're going to have to say, get the transform of each one and the shape, check with its position and its radius, check to see if the distance between them is less than the sum of the radii, and if it is, then there's a collision. So you have to do that for each of them. And now with an enemy, what happens is, if there is a collision, you have to spawn the smaller enemies, right? So that's why I have 2 loops here, because the collision logic is actually different to say if it's a small enemy or if it's not a small enemy. So when I spawn my small enemies, I actually give them a different tag than the big enemies because the logic is different between them. So I typically give everything in the game that has the exact same logic the exact same tag. So that's why I've done this. There may be a more elegant, fewer lines of code solution to that, but I don't really care. Just keep in mind that this isn't the only collision you have to do. You also have to collide the player with the entities and the player with the walls, but I haven't put that code in. In the rendering system, here is the GUI system. You just have to implement the GUI there. I won't go into that. You know what has to be done. The rendering system, what I have done is only draw the player, okay? So just keep in mind that what you have to do here is put in that loop that says draw every entity, not just the player entity. And the way I have done the extra thing that's very important is that over in the component of the transform has the position and it has the velocity. But there's an extra step to actually getting the shape to draw at the new position. So in the rendering function, what I do is I take the position, which is the transform. So this is the player's transform's position. Now I actually have to get the shape of the player and set its position to that. So the transform position is not the thing that SFML actually uses to draw the shape. It's the circle's position in the SFML circle shape object. So that's just the one extra little step. Because we're using an external library to draw these things, we have to make sure that we set the position. And similarly, because we have this angle that's changing over time, we have to set the rotation equal to the rotation as well. But that's it. And then you would just add in the loop to make sure you're doing it for every entity instead of just the player. The user input down here, this is where you would add the logic. So down here, I've given you sample code. If the W key is pressed, down here, you would set the player's input component of up to true. It is very tempting to try and do the movement logic here. Like for example, if our speed is 5, if the W key is pressed, then move the player up by 5. Don't do that. Set the input components up to true, and then in the movement system, that's where you read in, is the player moving up. And the reason we don't want to do it here is because in the next assignment, we will completely decouple the notion of pressing keys from performing actions, right? So let's not do that there. But for simplicity and your sanity's sake, down here in the mouse button pressed, so I've created a vec2f mouse pause. That's where the mouse is on the screen. You can call the spawn bullet and the spawn special weapon functions here, okay? So you would literally just call spawn bullet with the player and the target, and then spawn bullet would take care of that. I'm at my time limit, so that's why I'm kind of speeding through here. But that should be pretty obvious what this system is doing. And then you would also have to put in the if statements for W, A, S, and D. Okay? So you'd have to put in all those. And also keep in mind that that's that's the key release. Up here is the key press. So if it's key pressed, set it to true. If it's key released, set it to false.